So, water is one of the most limiting resources in agriculture. So, bentonite is an essential tool which aid in water conservation and for sustainable agriculture production. So, when mixed with soil, what happens? It absorbs large amounts of water and it forms a gel-like barrier with soil pores, which reduces deep percolation and increasing soil capacity to save more water and to improve soil structure. So this bentonite can be used in improving crop production under dryland agriculture. So it acts as a gelling agent, it acts as a water absorber, it acts as a nutritional dose for agriculture. So bentonite is one of effective tool which is a soil amendment which is non-toxic and used for water saving and soil and water conservation. So generally, clay particles are less than 0.002 mm in size. This bentonite is also a clay particle which is mostly made up of montimonolite and it is crystalline in structure which is pollutant free and non-toxic soil amendment. It has the properties of hygroscopicity, adsorbability, distensibility means expansion or contraction by pressure on pressure without rupturing and cohesiveness. It is mostly made up of antimonolite which is about 80% and rest 20% is of secondary minerals. Backside you can see the bentonite at different magnification. So structure of bentonite, it has large surface area and high thermal stability and it has some mechanical properties which are very unique in nature. So it is highly used as a absorbent. If you look at bentonite structure, it has two silica, two silica tetrahydrals, two silica tetrahydrals and one aluminum octahedral. This is aluminum octahedral, this is silica tetrahedral. This is called one sheet. This is called another sheet. The distance between these two sheets, different sheets, is called as despacing. If despacing is less, that indicates that these two sheets are very close to each other. This intermediate interlying space is made up of with water or some cations like calcium or sodium. Generally, bentonite is of sodium bentonite and calcium bentonite. These interlying spaces will be having this water. Along with that, it may have some sodium or calcium. Based on the presence of which metal, that is denoted as whether it is sodium bentonite or a calcium bentonite. This is the molecular structure of a bentonite. Generally, it has cation exchange capacity of 110 milliequivalent per 100 gram of clay. It is also useful in absorption of heavy metals like cadmium, nickel, lead and cobalt from a aqueous solution and from a waste. So this is bentonite structure. In between you have water molecules and it is surrounded by, it is a 2 is to 1. It is already, you know that it is a montimonite. Montimonite is a 2 is to 1 clay mineral. 2 is to 1 means two silicate layers in between one aluminum layer. So that is called as 2 is to 1 clay bentonite. So physicochemical properties of bentonite, it has high surface area, it has plasticity, structure 2 is to 1 clay mineral, it is highly adsorbable property, absorption capacity is high, it has cationic exchange of 70 to 110 milligram equivalent per 100 gram. So these are different types of bentonite, one is calcium bentonite and sodium bentonite. It can be used in the process of esterification as a catalyst. Esterification means where alcohol reacts with acid, where you will form ester and water. In that reaction, if bentonite is used as a catalyst, acid activated bentonite, and it is also useful in removal of heavy metals like cadmium. So these are the important properties of or uses of bentonite in brief. Coming to sodium bentonite and calcium bentonite, sodium bentonite forms a thick gel when it is applied in water, whereas calcium bentonite does not form any gel and it settles in the water. So in sodium bentonite, what happens? In between the layers, there will be sodium, which is monovalent. Since it is monovalent, it has higher hydration radius and it attracts more amount of water molecules, which will result in higher swelling. Whereas in calcium bentonite, where it is interlying spaces are having calcium, which is divalent, and it has high charge density. Because of that, what happens? It holds the clay layers very tightly so that it doesn't swell too much even when it is mixed in or even when water enters. So it has lesser swelling when compared to sodium bentonite. This is the major difference between the two. Swelling is higher in case of sodium bentonite, gel formation is high, viscosity is high, watering hold capacity is also high, and CEC also high in case of sodium bentonite. So it is used in drilling, etc. Whereas calcium bentonite, when compared to sodium bentonite, all other properties are low for calcium bentonite. It is used in animal feed clarification process. This is a major difference between sodium bentonite and calcium bentonite. So physical properties of bentonite, if you look at this sodium bentonite, see initially under desiccated condition, all the exchangeable cations that is sodium are tightly fixed this between these multimolite sheets. But whenever you are hydrating with water, what happens? This sodium attracts large amounts of water molecules and it swells. Because it has higher hydration radius, it swells too much, making it highly swelling property under hydrated state condition. This bentonite has both thixotropy and rheotropy properties. Rheology means what? Rheology means it is study how materials flow and deform applied force. Under applied force. Whenever you are taking a bentonite and you are stirring, it easily breaks and forms a thin liquid. And upon cooling or upon settling, it forms a gel. That is the important property of bentonite. That is what it is called as thixotropy and rheotropy. Upon time, it breaks and flows easily, and upon whenever it cools, whenever it settles, it again forms a gel. That is the property of bentonite. Next important property is permeability. Permeability is nothing but relative ease with which water enters into the soil or flows through the soil. That is expressed as coefficient of permeability, that is K. There are two methods. One is constant head permeability test. The other one is falling head permeability test. In this constant head permeability test, you are going to use in case of coarse soils or sandy soils, where head is kept constant and the volume of water is taken into account, where the difference between this tank and this funnel. So if there is more flow, there will be higher permeability. This is the formula for calculation of K in case of constant head method. If you talk about falling head method, we are going to take the difference between two heights, that is head decrease from H1 to H2. This is initial H, this is final level. Between the difference between two, you are going to calculate. This is the formula for falling head method. This is suitable in case of fine soils or silt soils. If there is less flow, that indicates lower permeability. How do you interpret? Higher K means more permeable, lesser K means less permeable. So bentonite, whenever you are applying into the soil, what is the permeability you are going to test after your application of your bentonite? If after, for example, initially without application, if the water is flowing too fast, that indicates the soil is highly permeable, means the deep percolation losses will be more. But after application of bentonite, the ease with which water will flow into the deeper layers will be decreased. This will be helpful for the soil to retain more amount of water, which improves crop growth. That is the purpose of this test. After application of bentonite, you should go for permeability test. If you look at this table, see different columns purpose. Before application of bentonite, after application of bentonite, what is the reason? In brief. So if you look at the water movement, before application, water flows very quickly. After application, pores will be filled with bentonite. So water flows very slowly because swollen bentonite blocks the soil pores. If you look at the water retention, before bentonite, it rapidly drains. After application, it stores some water because bentonite blocks the pores and absorbs the water like a sponge. If you talk about nutrient, because of deep percolation and leaching, nutrients will be leached out. Whereas after application, since the pores are clogged, nutrients remain in the root zone because of the lower permeability. Soil moisture conservation is high after application of bentonite. Crop growth automatically, if water is present, nutrients are present, crop growth will be automatically higher and after application of bentonite. So if you talk about erosion and runoff, more runoff before application of bentonite. After application, the runoff will be reduced, erosion will be reduced because there will be slower water movement and there will be higher infiltration and lesser infiltration rate, and there will be more soil stability and formation of aggregates, making the soil to be stable after application of bentonite. Next important physical property is free swelling test of soil and bentonite. What is free swelling? It is nothing but the volume increase of the soil or bentonite when it comes contact with water without any load. For example, this is dry soil or bentonite. when you're keeping it in the wild, how much it has swollen. That it is what it is called as free swelling. How you will identify? You dry bentonite at 105 degrees centigrade. You are going to take it, measure it 2 grams, and you are going to put it in a cylinder of 90 ml, and afterwards you are going to stay it for 24 hours. After that, you are going to take the volume. So what is the formula? Final swollen volume divided by weight of dry bentonite. For example, weight is 2 grams, final swollen volume is 30, then FSI stands about 15 milliliter per gram. Higher, so this is the index. If it is less than 5, low, 5 to 10 moderate, 10 to 20 high, greater than 20 very high. If you look at for soil, when you compare with kerosene, you are going to have free soil swell index in percentage. That means how much volume it has been increased because of the bentonite. So you are comparing with water and you are comparing with kerosene. Kerosene is non-polar, so that it does not expand or hydrate. Whereas in water, when you apply bentonite, it expands. How much it has been expanded because of bentonite, that you are going to measure in case of this test. Higher FSI percentage, higher swelling potential. What's the purpose of this test? To compare either sodium and calcium bentonite, how they are reacting. Sodium bentonite, it expands higher. Calcium bentonite, it expands lower because of calcium divalent nature, whereas sodium is monovalent and it hydrates more when compared to calcium. The other one is evaluate bentonite, how much water it is retaining. So this test gives you the best example. Kerosene provides a baseline. For example, after kerosene, there will be no swelling. If it is 10 ml, after application of bentonite, how much the water has been swollen? That is kerosene provides as a baseline. So to evaluate the effectiveness of bentonite, how much it is retaining water as a soil amendment. The other one is swelling behavior of clay soils. All these aspects can be known with the help of this test. So this test should be conducted at room temperature. You should use distilled water for accurate results. Next important is rheological test. Rheological tests are performed to understand the bentonite slurry, how it is performing. These are the different tests: viscosity, flow curve test, yield test, oscillating test, stress relaxation test, thixochropy test, and creep test. So why we have to go for bentonite study? Bentonite forms a colloidal suspension. What is colloid? Colloid is a stable mixture in which tiny particles remain suspended without settling, as seen when bentonite is mixed with water. Basically, colloidal size is 1 to 1000 nanometers. So this bentonite, after mixing with water, it forms a slurry, and it is a colloidal solution. All these tests are important to know the properties of bentonite, how they are performed, to evaluate the flow behavior, viscosity, stability of bentonite slurry, so that it performs effectively in water conservation, drilling and sealing applications. This is the importance of these tests. If you look at a study how bentonite after application on the soil performing the crop growth and grain quality in semi-arid regions, you have found that bentonite application in semi-arid regions highly improved soil water holding capacity, increased photosynthesis, water use efficiency, and grain quality. If you look at these results, after application of bentonite, what happens? This in between the clay layers, it is going to absorb more amount of water, and it is able to absorb more amount of nutrients and able to store in between the interlying spaces, which will be used up by the plant. Because of that, what happens? It is holding more amount of water. You will find more field water holding capacity and plant available water. If the plant available water is good, automatically there will be higher emergence rate, higher ground above ground matter, that is biomass, and there will be more photosynthesis. If there is more photosynthesis, automatically there will be more yield to the plant. And water use efficiency, why it is higher? Because it is able to save more amount of water with the given amount of water. Improved soil structure and improved water retention, more available water to the plant. This up to 40 centimeters. So this congenial soil environment for microbes and for better root growth, making the crops to yield better. So according to the research, what happened? Optimum for plant growth and photosynthesis is about 24 megagram per hectare, whereas for grain quality it is only 18 megagram per hectare of bentonite. So reasoning, if more water availability in the root zone, better germination, higher photosynthesis, and higher spared values, ultimately giving better yield. So based on this, you can conclude bentonite 18 to 24 megagrams as a soil amendment in semi-arid areas gives better results in both in terms of yield and soil water properties like soil water holding and retention and better nutrient absorption. So, bentonite is a natural clay mineral which is eco-friendly. What are its properties? It hygroscopicity, absorbability, distensibility, it swells in water, cohesiveness, binds particles, it is pollutant free, safe for environment. And it is also has rheological properties like thixotropic properties and rheolotic properties. And it, if you look at the permeability, it regulates the permeability nature of the clay particles. Because of the different properties of the bentonite, it is used as a desertification control. Basically, when you apply bentonite to a sandy soil, what happens in between the underlying spaces, it fills these underlying spaces and it forms a stable aggregates. Because of that, what happens, nearly if you apply 1% bentonite, it nearly has more amount of water. And if you go for 1% bentonite, along with holding of water, it also improves structure, making soil porous with 1% bentonite. And what happens if you go for 0.2% bentonite, basically in desert, the particles of sand will be sorted out. So after application of bentonite, what happens in between the sand particles, it fills these pores, it fills these spaces with bentonite and makes them tight, stronger in nature, holding in nature. Because of that, it is able to control or reduce erosion. And bentonite, if you go for 2%, it forms shear strength, means the energy which is required or pressure required to slide past each other, so it is higher than a biological crust. If you go for compression strength, if you apply for 5%, it forms compression strength, means the pressure what you have to apply to rupture it. So after applying bentonite, what happens? It is more stable and it requires higher strength to break the bonds. So if how it desertification can be controlled, generally wind removes at 6 mm per second or 8 mm per second, whatever it may be the speed, basically sand particles will be sorted out in air. But after application of bentonite at the rate of 0.2% or 5%, it forms stable aggregates. It binds the soil particles, sand particles, and it controls erosion and reduces erosion, and you can go for vegetation. So you have to remember, if 0.2% bentonite, it is good for controlling or reducing wind erosion, 1% bentonite for better water retention and improving of physical properties, 2% for best for shear strength, 5% compression strength. How it works? It fills the spaces and binds the particles because of its properties of swelling of properties, rheological properties, and increases water holding capacity by making the soil less permeable for deep percolation losses, improves soil strength and stability because of its higher shear strength and compression strength, and reduces wind erosion as it binds particles. Automatically, all these conditions will favor for better plant growth because of this coating of bentonite. So it is also less cost when compared to other raw materials. So bentonite is a natural, effective, low cost tool, environmental friendly tool, which is a smart strategy for desertification control and to restore land so that the cultivable land in there can be enhanced. As the land is day by day decreasing, so you should find a place to grow, and this place may be a desert. How can you grow? By applying bentonite, you can find a smart control strategy for restoring land and improving vegetation. Look at the wind tunnel and erosion rate experiment where your bentonite mixed with sand is kept in this tunnel, and afterwards this is kept on a sand table, and wind erosion. Wind is blown at different speeds like 6, 8, 10 meter per second, and afterwards this is sand table post erosion, after erosion. Afterwards you are going to look at the stability of the soil after blowing of air. Based on that you can find whether bentonite is successful in the maintaining the sandy soil intact or the sand is being spread out because of the air. And this is the compressive strength test before, and this is before and afterwards when applied bentonite. Look at the surface morphology of bentonite at 0 percentage, 0.2 percentage, 3 percentage, and 9 percentage when it is looked at under 150x magnification. Based on different researches conducted under deficit irrigation with application of soil amendment bentonite, they have found that decreased infiltration rate and deep percolation losses when bentonite is applied at 2 gram per liter. They have also found increase in maize productivity and improved water retention and structure of the soil. They have also found that soil water holding capacity was increased by 12% and plant water availability was also increased up to 40 centimeter depth according to Emelina. So in Fenugreek, they have found that after application of bentonite, the plant has recovered from stress when bentonite is applied at the rate of 0.5-10% at irrigation treatment of 30, 60 and 90 field capacity under sandy loam conditions. And other research found that water has been extended up to 60 centimeter depth and they have found reduction in EC, pH and bulk density levels by barley. These are the different researches where under deficit irrigation condition, bentonite application is found to be successful in water saving and water holding capacity and increasing water use efficiency. Based on the above discussions, we can conclude that application of bentonite will improve the field capacity. It may be ranging from 1 to 9% for 0 to 10 centimeters, 1 to 12% for 10 to 20 centimeters, and 0 to 11% for 20 to 40 centimeters. Along with field capacity, it also improves plant available water capacity up to 40 to 60 centimeters. Whenever bentonite is added to the sandy soil, it fills the interlying spaces, interspaces between sand particles and forms stable aggregates which helps in soil water retention and soil physical properties improvement at 1% proportion. Along with that, bentonite has significant proportion in maintaining desert areas. Lower proportions of 1% are useful for ecological restoration. If you go for 1 to 2% of bentonite, it is useful for sand fixing and wind prevention. High proportion, that is greater than or equal to 5%, you can go for topsoil reinforcement and slope protection. Along with that, bentonite creates more consistent wet soil condition where you'll go for more microbial populations and more enzymatic activity. If you combine bentonite with humic acid and biochar, you will find decreased bulk density and decreased electrical conductivity and soil pH. If you go for applying 2 gram per liter of bentonite, you will find increase in furrow length. Means there will be formation of thin layer of bentonite on this furrow where it is easier for agriculture operations and machinery to run, and also you will find more time for infiltration. Means opportunity time will be increased because of application of bentonite where furrow length is a crucial design in furrow irrigation system. And bentonite is very much important in case of dryland farming where rainfall is scarce, water is scarce. Under those conditions, if you go for bentonite application, you will find improvement in soil physical properties and you will find more water holding capacity, more retention to the soil. It also performs better when compared to your biological crust and better than salt crust. So based on this, you can conclude bentonite is an important soil amendment which is natural and provides best strategy for water saving and to improve vegetation and improve the soil physical and chemical properties. These are the different research studies references. Thank you.